A pleasant morning to all of you. So every successful story start with a step of one step of beginning. So, dear God, first we want to thank you for all that you have done for us. We hope that you will help us in the next step of our life. We will not ask for anything to you because you know the best for us. We trust you as you will be always with us. So, first, we thank the Almighty for all the things He has provided to us. So, in this session, I'm much happy to connect with Dr. M. Sivakumar, Associate Professor from the Department of Physics, Arahapa University, Karikudi. His area of specialization is energy storage materials and lithium ion, sodium ion, lithium sulfur battery materials, supercapacitors, fuel cells, polymer electrolytes, biofuels, crystal growth, and production of nanoscience and the study towards nanomaterials. SAR has published 137 research articles in international journals. Actually, every month nowadays we are seeing that at least two papers are publishing in reputed journals. We are very happy to connect with the Associate Professor, Dr. M. Sivakumar. Congratulations, sir, for all your work. You are succeeding.
Thank you, madam. Thank you.
Yes, sir, sure. And next one, Sarah has completed 10 PhD candidates successfully and about to 40 MPhil candidates also. At present, Sarah is guiding 6 candidates as a research supervisor and 3 students as a joint research supervisor. And next, Sarah has performed in many administrative posts as a program officer, NSS coordinator, MPhil Physics Weekend program. And next one, as NSS program officer, he has received many awards also. Sarah has completed 4 projects successfully with a total generation of fund 1.15 crore. At present, Sarah is doing one project, and for his research thirst, he has 1,326 Google citation scholars with high index of 16. And next one, he has gained the total impact factor of 290 from SAI papers. And Sarah is also honored for with many awards as a postdoctoral fellowship from Taiwan, principal Indian scientist for DST NSC sponsored Indian Taiwan Collaborative Research Project, and Best Oral Presentation Award from Satyabama University, Outstanding Reviewer Award from Electrochemia Acta, and also Sarah has received Dr. Adagapar Excellence Award from IQAC Adagappa University. So with this very nice profile, we welcome you, sir, on this forum to share your gracious moment with us. We welcome you, sir.
Thank you, madam. Thank you. You have a very lengthy introduction of me, and I am a little bit happy about things are moving very fastly. Before 2 years, we have jointly attended the refresher courses, and now you are the coordinator, and I am the resource person in this. So, the things are changed very erratically. Okay, very nice to meet you, madam. Thank
Yes.
you. Thanks for this nice opportunity given to me to talk on the faculty development program, which is organized by AICTE and in the BIT campus. I'm very much happy to thank Madam Dr. Kanimuli and her team for arranging this nice faculty development program. Being it is very important nowadays, we are looking for some kind of refreshments. So this kind of refreshment may be attending this kind of faculty development program and enrich your knowledge by in a specified area. Everybody will talk about their own specifications. With this, you can take up then and there, and you can mold yourself in a limelight of for your own students. And I'm very happy to talk on the role of alternative energy storage devices. Actually, this slide gives you my institutional profile. Alagappa University has been established during 1985 with 430 acres of just 10 departments. Nowadays, we are having 41 departments and several constituent colleges and other things. We have been graded as by NAC during 2017 with the 3 points highest score of 3.64 out of 4 with A plus grade. Madam, am I audible?
It is audible, sir, but the slide has to move, it seems. It is in the first slide, role of alternate energy storage devices.
Oh,
I think it should be moved to second slide.
no, no, madam, it is moving in. It is moving.
Okay, okay. Now it is okay, sir.
Okay. Is it moving, madam? Is it moving, madam?
Yes, sir, it is moving. Once
Okay.
again, sir. Once again, sir. So I request the participants, is the SAR presentation is in full view? Because we don't know whether it is in full view. For my yesterday's presentation. Yes,
No,
sir.
ma'am.
Yes.
Is it in full view,
Yes, it
madam?
is visible, ma'am.
Yes, sure, ma'am. Sure, Anandam. Thank you, sir. And
Okay, ma'am.
Professor Dr. M. Sivakumar, sir.
Madam.
Kindly present in the full mode, sir. Actually,
Yeah,
it is
it is in full
window.
mode. It is in full mode, madam. Right now.
Slide show, ma'am.
It is in slideshow, sir.
It is in slideshow, madam. I have made. I have made already.
Again,
Is it moving?
again use
Maybe.
the Control F5 button, sir. Control F5. It
One
will be F5, simply F5. A full laptop view is coming to us, sir.
Is it okay?
Now it is okay, Anandan, Mr. Ma'am, Jayprabha, ma'am.
No, ma'am, it is.
No, ma'am. Still, it's like that only. Slides.
Maybe.
Not
Wait a
visible.
minute. Wait a minute. I will provide the. I will share the entire screen. I will share
Yes,
the entire
we want that.
That is better.
Yes. Mask, sir.
Madam, is it visible? No.
No, sir, it is not in presentation mode, it seems.
Now I shared my entire screen, madam.
1 second, sir. 1 second. We wait for something. No?
I think it is coming.
Sir, Moscow, sir, welcome. Sir, presentation mode only, sir.
Is it visible, madam?
Now it is okay, sir. Now it is okay, clear.
Okay.
So is it okay, Madhu, Hema Malini?
Yeah, it's okay now.
Okay,
Yes, ma'am.
okay. Thank you.
It is, ma'am.
Thank you, Anandan.
Thank you, madam.
Thank you, Jayprabha, ma'am. Thank you.
Yes, ma'am.
Okay.
Okay. Right now we will come to the topic, madam.
Yes, sir.
as far as the topic is concerned, we are dealing with energy. Of course, everyone knows we need energy to do so any kind of work, and it may exist in any kind of forms like thermal, nuclear, chemical, electrical, any kind. So almost all the forms of energy can be dealt with the motion. Okay. Uh, of course, all the natural resources of energy are derived from the coming from the environment. Normally, we are consuming the energy from the fossil fuel. Almost 90 percentage of our energy has been consumed. Of course, we are day by day increase in the need of the energy consumption is increasing day by day, and nowadays almost the exhausting has been happen for the globe reservation of natural resources. Maybe it will deplete within very short duration, because due to the industrialization, population growth, as well as the economy, technology development. So we all need the natural resources, so which cannot be replaceable. So in this juncture, World Energy Conservation has predict that almost all the coal deposit will deplete within 200 to 300 years. Therefore, another thing is petroleum. It will be deployed very short duration, maybe within very 1 or 2 decades, because we don't have any resources in India. Uh, Dubai and other Gulf countries are having the petroleum products, but right now, what is the price? Sachin has scored several centuries in test matches and one-day matches, but petrol price has scored several century in several states and several districts in Tamil Nadu. Therefore, this kind of problem can be minimized or eliminated, or at least neutralized, based on the encouragement of R&D activities among the broad spectrum of renewable sources, which can be the contribution to be made substantially towards the commercialization as well as the utilization of the for the society, right? Okay, there are several modes of energies are available, which is nothing but mechanical, electrical, chemical, and electrochemical. Almost we are dealing with the electrochemical, because we are requiring the portable electronic market. Nowadays, it captures the entire world mind, because all the young people, old people, even the 1-year-old child can handle the mobile phone. So for that, we are needing to store the energy in that mobile phone. So how it can be made? Through the battery. So batteries of having in the several forms, like batteries, supercapacitors, fuel cells, stack, everything. Almost the batteries are having lot of forms like lithium sulfur, sodium, air battery, lithium air battery, magnesium air battery, zinc air battery, and all. So we are talking about the batteries. What is the actual battery? Almost all the energy storage devices are coming under the category of solid state ionics, which can be dealt with the flow of ions in solids at below their melting points of the uh, solvent. So we are talking about the batteries. It is nothing but the electrochemical cells to which store the electricity in the form of its chemical energy. There are majorly it is classified into two classification, such as primary and secondary batteries. Primaries are cannot be recharged or replenished, and secondary batteries is that can be recharged. So now we are talking about the battery, how it works. This slide pictures you the battery working principle. Here you can see the cathode, and you can see the anode. Here we have mentioned that the anode is graphite. So both the electrodes are pasted on the current collectors. See, this one is the lithium, and this is the electrolyte. It has been separated by a separator. So reactions are given here: total reaction, anode reaction, and the cathode reaction. So this slide gives you the actual functioning of battery. During charging, the electron, the lithium is moving from the cathode to anode through the electrolyte by means of the ejection of electron. Whereas during the discharging, it has been again went to the cathode through the electrolyte and the separator from anode to cathode by the ejection of again electron. Okay, so this is the simple mechanism that I want to show. And with this, there are several battery technologies are existed. Majorly zinc carbon. First, it started with the Laclanchi cell, and it has been developed as a zinc carbon battery, that is a AA battery like this. AA battery like this. Whether my camera is visible? Are you able to see?
Yes, sir.
Okay, madam. Thank you. Alkaline battery, majorly named as Duracell or Energizer batteries. The lithium iodide battery for pacemakers and hearing aids because of its longer cycle life. And the lead acid battery, nickel cadmium battery are taken into the picture, are coming into the picture for the automobile engineering. And the nickel metal hydride has been developed due to its uh, entirely not not suffering from the memory effect. Therefore, nickel cadmium batteries are used. Lithium batteries have been established because of its very high power to weight ratio. That is the major criteria for lithium ion battery. It has been used in high-end laptop and mobile phones, etc. So, and maybe more battery technologies like zinc air battery, zinc mercury battery, silver zinc battery, which can be used in the aeronautical applications. Out of all, lithium-ion batteries have captured the very big position in the electronic market, such as 63% in the uh, market. It is due to the application, various applications like power sources in the portable electronic market, like mobile phones, camcorders, camera mobile, and like they say, anything. Almost all the electronic equipments are made up of powered with the lithium-ion batteries nowadays. And also nowadays, government is encouraging the electric vehicles towards the environment, to eliminate the environmental pollution and secure the and neutralize the petroleum need. Therefore, for one such a commercial batteries, we need some the given factors. The very important factor is working voltage. Of course, hope you can see this Nipo battery. What is the actual voltage of it? Everyone knows it is 1.2 volt. And for how many of you have seen your mobile phone battery? It is made up of the lithium and phosphate battery, lithium polymer battery. Maybe they have put in that. You can see it is about a 3.4 volt. Some of the material are exhibiting 4.2 volt or sometime 4.5 volt. Maybe based on the material it plays. So the working voltage should be high, and there should be very less change during the discharge, and that voltage should not be decreased upon using the material. Also, we should have the high capacity, Coulombic efficiency, and high power. Also, it must have a longer cycle life. For a normal battery, Sony Corporation established this kind of batteries, and they have tested for almost minimum of 2000 cycles. Minimum of 2000 cycles they have cycled and tested the material. Therefore, after that they have make it as the commercial one. So for commercial purpose, we need to work it on much more. But R&D activities, it is just compromised with just 100 cycles or 200 cycles. Sometimes based on the intents of research, they are going beyond 500 cycles, something like that. And chemical stability, electrochemical stability, it should have the wider potential window of the material, electrode, electrolyte, everything. And also there is no decomposition of the electrolyte. Of course, everyone knows if you keep the batteries for a longer duration, maybe if you are not using, even though if you are not using, you can keep it somewhere. What will happen? The oozing of electrolyte will be happen. நம்ம தமிழில் சொல்லணும் அப்படின்னாக்கா மேபி வி ஆர் யூஸ்வலி டெல்லிங் ஆஸ் பொங்கிருச்சு அப்படின்னு சொல்லுவோம். பேட்டரி பொங்கிருச்சு அப்படின்னா தட் இஸ் நத்திங் பட் த எலக்ட்ரோலைட் இஸ் ஊசிங் அவுட் டியூ டு த வாலட்டிலிட்டி ஆஃப் த electrolyte solution used in the battery. So that should not be happen. Of course, out of all, the material availability is the vital factor of choice of the commercial batteries. It should have the availability. For example, maybe later I will tell you the fact. What are all the components in the batteries? Electrode, electrolyte, as well by in the electrode it has been named as anode, and another side is cathode. Another side is cathode. The some cathode and anode materials are listed here, and this TAS2 is established during the first fabrication of batteries, lithium batteries. And here all the charge carriers are transported using the electrolytes. Most of the common commercial batteries are used in the liquid electrolyte. But I already pointed out the leakage. Due to that leakage, the solid polymer and the gel polymer electrolytes are existed. Of course, polymer electrolyte has been used for its wider potential window, and so also the dimensional stability of the material. Of course, everyone knows the separator is made up of the polymer, polyethylene separator. That polyethylene separator has been made into a conducting one. So by means of making that polymers in different monomers, we can use the material with a very good dimensional stability, and other choices are there. Of course, we are talking about polymer. What is polymer? It is nothing but the many monomers are combined together in a chain form, and it has been used in the batteries. For characterizing the polymer, in any polymer, if you want to characterize, you have to go for the thermal studies. Why? Because it is the very important factor as far as the polymer is concerned. Because the while we are increasing the temperature, see, of the polymer, the local motions normally, then and there the atoms are placed. While you are giving in the thermal energy initially, there are the local motions are taken place at T gamma, and if you make it if you continue the temperature increment, what will happen? The local motions are happen, and the formation of clusters, and it make the polymer as tough as possible. So that temperature termed as T beta, and further increase of temperature causes the material from the crystalline state to the rubbery state, from the crystalline state to the rubbery state. So that temperature called glass transition temperature, which is the vital factor of any polymer. Of course, if it is the pure crystalline polymer, what will happen? There is no TG, it exists like this, straight line. Whereas if it is the amorphous polymer, what will happen? The rubbery plateau, it will be transformed in the crystalline state to rubbery state. So it enters into the rubbery plateau. For some semi-crystalline polymer, the crystal slip will be occurred upon further increment. Whereas if it is the amorphous polymer, the pattern will be like this. Of course, again, if you increase the temperature, the the polymer starts melting. For some thermosets, we don't have any TM. Of course, the best example is your flask. Flask use பண்றீங்க. So that flask is the best thermoset example. So okay, after characterizing, the polymers are chosen for based on its unique properties, and the polymers are polymer electrolytes have been prepared using the conventional solid solution casting technique, or Dr. Blade method. Of course, all the polymer are polymers, and the alkali metal salt that you want to employ, you can separately dissolve in a common solvent like alkali metal, like a THF or dimethyl formamide or DMSO, like this. You can mix together and to form a homogeneous slurry. After that, the solvent was evaporated, then it was casted on the Teflon sheet or the flat bottom petri plates. Finally, it has been dried under vacuum, and the freestanding film was obtained for the fabrication purpose. Of course, this slide gives you the actual battery fabrication. After making the electrolyte solution, electrolyte film, the active material cathode and the anode has been prepared. For half cell, lithium foil has been used as the one of the electrode, and the cathode, for here I have given the LiFePO4 lithium iron phosphate. The active material and the conductive carbon light CB. Carbon black or any super P, anything can be used, and for making the better electronic conductivity. And also the PVDF has been used as the binder material. All the three has been mixed in the NMP solvent. After that, it has been mixed, then it was coated in the aluminum foil. In case of anode material, if you prepare, the similar material preparation has been same, but the foil is used as a copper foil. Then after coating, it was roll pressed towards to have the better conductivity between the better contact between the electrode material as well as the current collector. Then it was slitted and assembled in between. The polymer electrolyte film has been sandwiched between the cathode and foil and lithium foil. In the cell case, that is 2032. Normally, we are using the 2032, this case. See, using this case. Is it visible? And finally, it was sealed and subjected for various characterizations. See, can you see the coating machine? This is the actual coating machine. Here we are pouring the slurry. So these are all the. This is the foil. Here you are seeing the copper foil. We are preparing the anode. This is the solution. This arrangement is the hot air is blowing here, and this will be moved from here to here. During that time, hot air is passed, and the solution, the solvent is evaporated, dried. Then it was obtained here and rolled here. So see, you can see the pouring of anode slurry. This is the anode slurry. To make it uniform, we can make the adjustment here. See, after blowing the air, it was dried. This is the anode film. After this drying, it was roll pressed during this by using this roll presser. to make it almost 40 micron, 50 to 70 micron thickness of the electrode. It gives the better contact between the electrode material as well as the current collector. This is the electrolyte film. These are all the cell cases, and it has been sealed using the vacuum sealer like this. All the fabrication have been done under the dry room facility with a minus 45-degree dew point. I think you can see the entire preparation here. Will it be visible? Please tell us. Tell me. See, here we are preparing the cathode slurry, anode slurry. Is it visible?
Yes, sir, it is visible.
Okay, madam. Okay, madam. Thank you. Almost we are preparing the cathode slurry and the anode slurry like this by means of the homogenizer. See, then this is the arrangement. We are pouring the solution here. Here the already the roll is formed, upper roll, through the drying facility. Here this is the roll pressure, and see, we are pouring the slurry here by means of adjusting the thickness of the material. We can completely appropriate amount of material has been taken, and the slurry has been formed. After that, after mixing through the homogenizer, it can be put in the. Now it is moving. The uniform thickness you can see. It is enter into the heating arrangement hot air blower. See, these are all the entire dry room facility. It is a very big 600 square foot dry room. It is situated in national facility of Taiwan. That is nothing but Industrial Technology Research Institute situated at Hsinchu. You may not believe that the actual establishment cost is different, but maintaining such these are all the this is the cathode, that copper foils are anode. This is nothing but the pouch cell can be made using the instrument. See, this is the this one. These are all the prepared one. Here you are seeing the slitter. uh, this is also the slitter, electrode and the electrolyte. This will be cut for the electrolyte film or separator. This is the sealer. This is the sealer. Ton and ton, several tons of pressure has been given here. See, big size batteries also can be done here, and here you are seeing the electrode, longer electrodes have been prepared. And this is the dry room monitors. See, you can you are able to see some in some pictures, like I think Dasavadaram, Kamal Hassan film. This is the blower, blowing of air is there. After that, you can go outside. See, all the control unit are here. This is the entire dry room. To maintain such a condition, we are they are spending more than 500 million ton, million dollar US dollar for maintaining purpose. For maintaining purpose, they are giving 500 million US dollar per month. So this is the entire lithium source and sodium sources have been kept inside the dry box. That means a glove box with just 0.6 ppm of hydrogen, water, and um, O2. So these are all the sensor. Okay, I think it will be very useful. This is the coin cell assembly. The bottom and the top portions are given here. But the spring has been used to get the proper appropriate contact between the electrodes and the separator. The right hand side is measurements are giving, the dimensions are given. See, this is the polymer electrolyte fabrication. Uh, See how smooth it is. This is the polymer electrolyte film that I made over there. These are all the lithium foil and other cell cases. Okay, after fabrication, the electrolytes are subjected, batteries subjected for electrolytes are fabricated, subjected for AC impedance, ionic transference number, lithium, linear sweep voltammetry, and charge discharge, cyclic voltammetry, everything. But the pure material has been used to study its surface morphology, thermal stability, and the complexation, other crystal structure, everything, fundamental vibrational group, etc. Okay, after preparing the polymer electrolytes, this slide gives you some examples of SEM pictures. By making the polymer electrolyte film with PVDF, triflate, triflate BF4 perchlorate anions. See the difference. See the difference of the close packing and the networking. Everything is happening by making the polymer electrolyte film. All the materials are subjected for FTIR analysis. By using this kind of assignments, we are studying the functional vibrational group happening. Like, for example, OH stretching can be assigned, has been assigned in this range, that is around 3600 to 3200. And I see double bond O is around 1720. Like this, all the functional vibrational groups of your polymer or materials or organic, inorganic materials. Some for inorganic materials, you may have very few assignments, but whereas the organic compounds have several assignments. So based on this, we are studied the functional vibration group of the prepared materials. So this is the DMA analysis. For example, for just the position of methyl methacrylate has been changed. Ethyl methacrylate and methyl methacrylate have been used, the electrolyte material. So you can see the temperature curve, that is DMA curve of such materials. How different, how much difference it has. See, it has the PMA as the higher modulus. So based on this, we are preferring the materials. After characterizing the materials, we can make use of the material in the fabrication of lithium batteries. So there are some examples of cyclic voltammogram using the gel polymer electrolytes in the half cell, FePO4 and the lithium. You are seeing that a very flat plateau that is happening at 3.7 and 3.2 oxidation and reduction happens. So now we are coming to the cathode material, how we can prepare and we can characterize the materials. Purely it is all the cathode and the anode materials are based on its structure, that is one-dimensional olivine type, and two-dimensional layer type, and three-dimensional spinel type. So, for some examples are I have given. The most commercial commercial electrode materials are LiFePO4, LiCOO2, LiMn2O4. So, one-dimensional, two-dimensional, three-dimensional. And almost all the materials are characterized for its structure using that Bravis lattices. It has within the 7 unit cell type, it must have one type. And see, this cubic, tetragonal, orthorhombic, hexagonal, monoclinic, triclinic, and trigonal. Of course, it has the 14 Bravis lattices. These are the unit cell types, and the cell parameters are given substantially simultaneously here. A, B, C, and the angle alpha, beta, gamma. Based on that, it has been 7 shapes. And of course, for the best battery cathode materials, commercially available materials are given here: LiCOO2, LiMn2O4, LiFePO4. This one is two-dimensional, this one is three-dimensional, and this one is one-dimensional. Its theoretical capacity is LiCO2 is 273. For LiMn2O4, it has 148, and for LiFePO4, it has 170. But practically, we can attain only 160 for LiCO2 and 120 in LiMn2O4. But it can be obtained the full theoretical capacity of LiFePO4 169 or 170 with the operating voltage of 3.6, 3.8, and 3.4 volt respectively. But the electrical conductivity is higher for the two-dimensional and three-dimensional, whereas for LiFePO4 it is electrical conductivity is very poor and poor diffusivity. Of course, based on the thermal stability, it is highly unstable for LiCO2 and Mn2O4, whereas it is very much stable. So, a lot of advantages as far as the LiFePO4 is concerned. Therefore, almost all the most of the companies are using the batteries with LiFePO4, but it has the mentioned drawbacks. So, uh, almost all the materials have been prepared using the common material methods like co-precipitation method, um, solid gel method, solid state reaction. In that just we have prepared the raw materials are mixed together and decomposed at 300 degrees centigrade at inner atmosphere. Further, it is heated in the furnaces around 800 and 900, something like that, by passing the inert gas into it. Then it was cooled into the room temperature. Finally, the material has been obtained. Like this solution casting. Here also we are using almost the higher temperature. But while we are using the noblest on polyol material, polyol process, we can take the acetate precursor and the materials, and it is refluxed and mixed or dissolved in the polyol solvent. After dissolving into the polyol solvent, it has been refluxed for several hours. It needs much time. After refluxing, it has been washed and prepared, washed and dried under vacuum. Then finally, the materials are prepared. Most of the polyol solvent are having the evaporation temperature around 200 to 300, around 250 to 300. So the preparation method is highly in the safer zone, that is around just 300, very low temperature method. But it is energy efficient because the energy is not released and it has been secured again and again inside the material. So the byproduct has been cast in the water, cast outside, that is nothing but the water. So based on that polyol process, LiFePO4 has been prepared by DK Kim and JK Kim, and they have developed a very big technology of polyol method, and they have patented it, of course. See how smooth it is, the LiFePO4, with very smallest size. You can see the sizes. It's about a 500 nanometer. This one, you can see the size of it. So this TEM picture gives you a very clear information about its size. You can see the orientation, how perfect, and it is just a 10 micrometer size, and the orientation of the height and breadth. You can see needle type. So while preparing this kind of material, it exhibits very close to its theoretical capacity. Also, we are able to prepare some brannerite electrode materials in our lab. See the crystal growth of the brannerite material, which has the AB206 pattern of preparation. And it has you are seeing the TEM and selected area electron diffraction here, how perfect orientation it has. So this slide gives you the actual amount of capacity. It's about 170 at 0.1 C. So that is nothing but it's a theoretical capacity. So based on this LiFePO4, we have prepared in Taiwan and made this electric vehicle for demo purpose. Of course, so far we have talked about lithium. Now, how much lithium we have in our country? Whether we have any resources? Definitely not. We have very, very feeble lithium sources in some very few places. Maybe almost all the lithiums are imported, but in Australia, US, and other very few Europe countries have lithium resources. So how come it is possible to have such a very big dream like a EV electric vehicle? So we need to have some alternative. Now here we are straining about the importance of the alternatives. Of course, and lithium is the noblest one. We cannot beat it. We cannot beat it. Of course, if we have, we are blessed. If we have the lithium resources, we have blessed. But unfortunately, we don't have much as lithium resources. So how come it is overcome? Through sodium and by preferring sodium, sulfur, and other air batteries like this. If we choose, we can have some alternatives. So the actual material availability is very important as far as the any commercial battery is concerned. So that in that aspect, we are moving towards the alternative. We are forced to have such alternative. So in this kind, we are everyone looks at the sodium, because sodium is abundantly available, especially in our country. It is abundantly available and with a low cost, very low cost. Normal we are buying the salt with very few rupees. So the safety is so high. As far as the electrochemical properties of lithium is almost matched on par with the sodium has electrochemical properties in par with the lithium. But only thing, what is the major difference? I will show you. This is the major difference. See, the why it is preferred is 0.7 Armstrong unit of cationic radius, whereas sodium has 1.0 Armstrong, 1.02 Armstrong unit as far as the cationic radius is concerned. But remaining all other properties are almost the same. But whereas lithium material needs to store Yeah, for handling. For this purpose, we need a separate environment, like a dry room or dry box, any kind of facility. Whereas this kind sodium material can be used. நார்மலாக அதை எப்படி போட்டிருப்பாங்கன்னு தெரியுமா உங்களுக்கு? Can anyone know? கெரோசின்லேயே போட்டு வச்சிருப்பாங்க. It can it will not hygroscopic much, so that we are keeping it in the kerosene itself sometimes. So this kind of advantages of sodium is preferring the low cost technology, whereas the lithium is high cost technology, so that we are looking for the better alternative. So in that sense, we are moving towards the alternatives. Okay, after compromising ourselves towards the alternative, let us go for the sodium battery, electrode materials and its structure. Normally, the battery material, sodium battery materials, sodium battery materials are classified into layered and maricite. Actually, now let me explain the prismatic type, and it is in octahedral site. So mostly the sodium is situated at the prismatic site and the octahedral site. That P2 type, O2 type, P3 type, O3 type. P2 is nothing but AB, BA, AB, BA. Whereas the octahedral type AB, AC, AB, AC, like this. For P3, AB, BC, CA, AB, C, AB, BC, C. For O3 type, ABC, ABC, AB. Like this, the atomic arrangements are there. It has been classified based on its the placement of A, B, C atoms. The P2, O2, P3, O3 types are existed. Now, as far as the all one-dimensional material is concerned, maricite and olivine type are existed. Actually, that edge sharing and the corner sharing I have put, I will explain in the next slide. The maricite structure of sodium iron phosphate and the olivine structure of sodium iron phosphate is given here. Say this one is edge sharing and this one is corner sharing. I will explain the edge and corner, everything. You are seeing that slide, the octahedral site. From this itself, I will explain all the things. Octahedral site, the faces, how many faces it has. You can see this is the octahedral site. See this one face, two face, three face, four face. Like this, we have another side, this side. See the other side of this. 1, 2, 3, 4. 4 plus 4, 8. 8 faces are there, and the corners are 6. See 1, 2, 3, 4, 5, like this. It has another corner on that side, so 6. So 6 corners and the edges. 1, 2, 3, 4, 5, 6, 7, 8, like this. 9, 10, 11, 12. So all these are explained very clearly here based on that faces, corner, edges. A prismatic size has a prismatic arrangement has 5 faces, 6 corner, 9 edges. Tetrahedral has 4 faces, 4 corner, and 6 edges. So as for based on this structure, maricite materials are having very much electrochemically inactive due to the poor cationic channel, because it has been closed. The edges are closed. Edge sharing is possible. Therefore, the sodium movement is restricted. Whereas in the olivine structure, it is electrochemically active and ion exchange is possible. See, here the motion of lithium, sodium is black. Based on this, we have developed several layered material as well as the maricite and olivine materials. We have made the material manganese, sodium manganese phosphate by polyol process through the different manganese precursors like chlorate, sulfate, and acetate precursors. Manganese acetate, manganese acetate, manganese sulfate, manganese chlorate. Okay, all the materials have been prepared and studied for its structure and fitted with the refinement, rate well refinement. Whereas the Raman analysis has been performed to study its chemical structure of the materials. The FTR has been preferred for studying the functional vibration group. You can see the structure difference while using the chlorate, sulfate, as well as the acetates precursors. See the network formed here, and that's. As far as the electrochemical property is concerned, because while we are preferring the maricite, we are looking for the electrochemical activity. To make it, normally maricite will not be electrochemically active. So we are towards making it conduct or towards making it electrochemically active. We are preferring this experiment, and you can see the chloride based sample exhibits just 1.6 milliampere hour per gram. While using the sulfate, it exhibits 5.07 milliampere hour per gram. You can see. Whereas in while using the manganese acetate precursor, the material formed very nicely, whereas it exhibits 102 milliampere hour per gram for the first in the first cycle. And it can be sustained for 100 cycles with the best Coulombic efficiency of 100. So even after the 100th cycle, it exhibits around 54, almost 50% is retained. So the retention is 54% with the efficiency of 97. So this makes you a conclusion that the active material, maricite materials are prepared with the different manganese precursors by controlling the pH, and the chlorate and sulfate precursors employed material exhibits very poor electrochemical performance because of it is acidic in nature of the polyol solution. How it happens? While using the acidic nature, it has been the sodium has been washed out, and it must have the poor crystalline stability, poor crystalline formation. That crystalline formation makes you the material as very poor in its electrochemical process. Whereas the manganese acetate precursor are expected to have such a wonderful pure phase maricite NaMnPO4, and rod-like structure makes you the exhibited and the exhibit makes you the maricite material, and exhibits a very good electrochemical stability as well as the activity with the specific discharge capacity of 102 milliampere hour per gram. So our aim is to make it act electrochemically active. It has been done, and it gives you a very good result that 102. It is almost about its theoretical capacity is 155. Just by 1/3 we have almost 70% we have attained. Also, we have prepared some prismatic type prismatic layer type method, layer type electrodes, and with the anionic redox activity. See, we have preferred the material sodium nickel manganese oxide material. We have preferred two methods. One is solution casting, one is salt gel method, and another one is solid state reaction. See, we have prepared the material with the electrodes in a lengthy way and made it as the some kind of pouch cell also. We have almost all the both the materials exhibited a very nice P2 type layer structure without any impurity, without much impurity. You can see the sodium 2 by 3, Ni 1 by 3, Mn 2 by 3, and O2 by 3. So see the structure, hexagon structure is very nice. You can see the from the temp, and based on the ACAD, the crystalline pattern have been, the diffraction pattern have been confirmed. As far as the electrochemical activity of the P2 type layer material is concerned, it exhibits it exhibits the very good cycling property, like in the CV, as well as in the charge discharge. It exhibits around 240 milliampere hour per gram. Why? Because it is based on the anionic redox activity. So based on this material, it exhibits a 244, and in the voltage range, it has been operated in the voltage range, cycled in the voltage range of 1.8 volt to 4.5 volt, using the 1 molar NaPH6 in propylene carbonate. So it has been substantially high among the other literature values. Uh, from this work, we have concluded that the material has been prepared with two different methods, and it exhibits very high profile material in the surface morphology, but it has the surplus capacity and the Coulombic efficiency. Whereas this material can be defended with the anionic redox reaction for the charge compensation mechanism. So, based on this kind of result, we are using this material as the parent material, P2 type Na, Ni, Mn, O2. We are looking for some other experiment, like for the pristine P2 type material. While you are overcharging, that means beyond 4.2, if you go for the charging, what will happen? The sliding of transition metal layer will be occurred by means of ejection of nickel ion. So there is a Na vacancy is formed here. The Na vacancy is formed here. That has been neutralized by using the inactive zinc, which holds the entire structure intact. So this will be studied, and using the same with the various proportions of Zn, that is 0.07 and 0.1 values. So here also we have attained a very good perfect structure, whereas the electrochemical results are a little bit different. However, we have a very good profile. The extension of cycle life is deferred while using 0.07, and the 0.1 is used. 0.07 and 0.1 is used. This one is 0.7, this one is bare, this one is 0.07, and this one is 0.1 zinc values. So to hold the structure, you can see from this, it has been, the structure is maintained. There is no much deviation. Even in the 30th cycle, it exhibits 120, 125. Here, 140 we are reached. So it has been operated in the range 1.5 to 4.5 at Zn is 0.1. It exhibits the initial capacity of discharge capacity of 205 milliampere hour per gram. So based on the materials choice towards maintaining the sliding of TMO layer, ZN has been used in different values, 0.07 and the 0.1. Of course, this ZN substitution strongly overcome the technical hitches of this material, and by entangling the structure, since it has the valency of close to nickel. So it sustains the actual structure and of P2 type and upon cycling. Also, it is very much interesting to note down, for previous case it has been cycled in 1.8 to 4.5. Here we are used in the cycling in the window 1.5 to 4.5. So this will be the limelight of our work. So based on that, like this, we have developed several cathode as well as anode material, carbon anode material also we have prepared, and we have prepared our own PVDF SiO2 phase inversion through phase inversion method, PVDF SiO2 membrane. In this composition, we have exhibited the around 4.7 into 10 power minus 2 Siemens per centimeter for as far as the ionic conductivity is concerned. And based on this, the red one, we have picked up and made a full cell. Normally, what is the difference between half cell and full cell? Half cell is nothing but if you use sodium or lithium as the reference electrode, and another one is intercalated material, that the cell is called half cell. In both sides, if we are using the actual intercalated electrode, hello?
What? Good job. Okay. Hello.
The participants, kindly mute your audio, please. Mr. Praveen Anthony. Yes, thank you.
Okay. Based on this optimized materials, we have formed the full cell and tested. See, it is really worthy to mention here. One of my students, Mr. Arjunan, has developed. We don't have any much technology and fabrication technology. By hand, we have made the pouch cell. Pouch cell, you can see this is the pouch cell made by us. And another thing, we have made everyone knows about the Amardanjan bottle. That Amardanjan bottle, normally all the battery material, batteries are fabricated using the metal cases. But in our case, we have taken the lid of Amardanjan bottle and we have make it as the plastic battery and run the watch, digital watch. You can see this is one of the finest maybe invention or not, we cannot, so far we have not claimed because we have published this work as the paper, so we cannot claim that, but it is the very interesting work done by us. And we have also tested the prepared fabricated battery through the householding material equipments, like through the transistor. It has been amplified and we have tested the performance. See, in other form like the traditional cell arrangement, this one for electrochemical cell arrangement, and we have also tested in the digital as well as the analog clock. It has been worked more than 2 weeks. So it is a very good attempt made by my student, Mr. Arjunan. And another student has made a very interesting problem, taken a very interesting problem. We can take one material and we can use it for multiple purpose, like lithium-ion battery. We can employ it in sodium-ion battery, and we can use it for supercapacitors. So he has the intention to study that, prepare a material to study that material in all the three cases, how it is possible. So he has taken the cobalt doped layered nickel oxide material, and he used that material LNCO as the 3-in-1 electrode for the electrochemical applications, storage applications. He has taken this LNCO to make it like this. But what is the actual issue happened in then the structure is very different, and it is not stable. So to make it stable, he has the objective like this. Based on that, he prepared the LNCO and characterized for its structure. And you can see the same images of his preparation LNCO material. And he fitted with the SAED pattern along with the XRD diffraction pattern, X-ray diffraction pattern. He made the cells using that material with lithium metal and sodium metal, as well as he subjected it for supercapacitor. See, you can see this CV while we have employed with the lithium metal. The insertion and extraction, as far as the lithium is concerned, it is no problem. So it will enter into the structure during cycling and lithiation and delithiation. It has the very good rate capability also, and with the best cycle life around 200 cycles at sustain. You can see this is not a very big achievement as far as the sodium material is concerned. Sorry, lithium metal is concerned. Here it is the very important factor. While using this material in sodium, you can see the oxidation and the reduction phase. That gives the material can enter into the layer structure and return back to its original position very nicely while you are doing the charging and the discharging. So it has been found by my student, and he has made the rate capability too. It exhibits the very good profile on par with the lithium. So he succeeded in this way, and also by employing this material in the supercapacitor application. He made a separate device, and he studied the charging and the cyclic voltammetry as well the charging and discharging. So it exhibits around 350, around 325 farad during its charging and discharge with various current densities. So with this, he made the conclusion that the major query of him is how the sodium ion can intercalate into the LNCO. How the sodium ion can intercalate into the sodium into the LNCO by means of the presence of anodic and cathodic peak of cyclic voltammogram in the while we are employing that material into the sodium ion batteries, which has strongly confirmed the diffusion of sodium into the LNCO layer. Actually, the interlayer distance between the of the LNCO is 4.73, whereas the ionic radius is 1.02, which makes it confirm it can penetrate or it can sustain inside the interlayer of LNCO. So that is almost defined one now. So we can proceed further. Based on this, we can confirm that sodium ion can easily accommodate the layer, into the layer structure. So now we have we are saying that we are the first one to have such LNCO can be used as 3-in-1 purpose, 3-in-1 energy storage purpose. Now, okay, as far as the lithium ion is concerned, we have moved several aspects, and based on the cost and other things, we have another material is sulfur, which is very inexpensive and non-toxic. This is nothing but the 10th most abundant. It's the madam, please. The
Yes,
participant can
yes, sir,
mute
sure,
their
sure.
audio.
Sure. Kindly, the participants are asked to mute their audio, please.
Okay,
Yes, sir, sure.
since okay, madam. Since the sulfur is also having very good capacity, it's about 1,675 milliampere hour per gram with a very good performance on par with other materials. It has been used. This dragon plot gives you the usage of a lithium sulfur battery based on its performance. It has 5 times the specific energy of lithium ion, as well as 2500 watt hour per kg it has. So it has the very good, it is easily available. So, but it has some challenges like poor conductivity of the material. Also, it during the charging and discharging, what will happen? The volume of the sulfur has been expanded. So that volume expansion will lead to the very drastic decaying during charging and discharging. So what will happen? We have to reduce the volume expansion of the sulfur. Also, there is a concept of shuttle effect. Shuttle effect, it is the schematic is given here. I will give you a better video for this, and these are all the issues to be solved as far as the sulfur material is concerned. A true hierarchical porosity has been maintained, dimensional stability of the material is maintained, and the electronic conductivity and the functionality has been improved. This is the actual working principle of sodium batteries. See, this is the actual working mechanism during charging and discharging. See, this is the lithium, and this one is the sulfur electrode. While the charging, there is a long polysulfide Li2S8, while lithium is breaking that into Li2S4 and Li2S4. Further, lithium ion moves and it makes it possible Li2S2, Li2S. So after that, this, okay, you want to see, the lithium ions are moving from lithium to sulfur electrode. And the long chains are breaking into half. Li2S8 will be there. S8 will be made it as a S4, and S4 has been made it as a 2, and then Li2S. See, but what will happen now? This Li2S and Li2S2 in the lower order polysulfide, it has been a very big problem that it has been dissolved in the solvent, that is electrolyte solution. So that cannot be replenished. So that is the major problem. That is nothing but the shuttle effect. So that shuttle effect should be minimized. This is the mechanism, the equations for the shuttle mechanism. Initially, it is S8, and it is combined with lithium, 2 lithium, and 2 electron. It made it as Li2S8, and it becomes Li2S6, Li2S4, and lower order. Second one is Li2S2, Li2S. Final discharge products are the primarily mixture of Li2S2 as well as Li2S instead of Li2, pure Li2S. So that should be a very big problem as far as the sulfur battery is concerned. So these are all very much easily managed by us by means of using the carbonaceous material, that is biomaterial, biomass material, to enrich the electrical conductivity as well as the volume expansion, to reduce the volume expansion by means of reducing the shuttling effect too. See the lychee material. This is the lychee shell. It has been prepared. Actual sepiolite is one of the most important clay mineral, which is the microcrystalline non-graphitic form of carbon, and it has the carbonaceous absorbent. Therefore, it has been used. It has been attracted our focus to use in the sulfur battery materials. So to make it as the composite, and then we have used that material in the sulfur, and with other biomass carbon, we have made it as the better electrode material for sulfur batteries. The for the activated carbon materials are used to used in the indoor air decontamination, food industry, drinking water, everything it has been used. So towards this background, the carbons are used in this study, and preparation of carbon material from the lychee source have been pictured here. It is the lychee cell from the lychee fruit. The lychee shell has been separated, and it has been pre-carbonated at 300 degrees centigrade. Then it was immersed in the chaos and the ethanol solution. After that, it was dried for several hours, and it is carbonized in the furnace. Finally, it was washed and dried at a 120 degrees centigrade. This is the lychee shell based carbon material. Based on the biomass derived carbons are used to have the better electronic conductivity of the composite sulfur cathode. Actually, it has been made as through the pyrolysis process. Using that sepiolite lychee cell based sulfur electrodes, it has been characterized for its structure and for a better structure. See this, the S double bond O structure gives you the better result for the actual happening in the composite. Sulfur is easily formed as SiO, and it gives you the appropriate strength towards the volume expansion. See, and the XPS gives you the actual. This is the the survey spectrum, and the individual deconvoluted spectrum of Si2P, Si, and C1s and O1s are given here. Okay, let us go for the SEM images. You can see this SEM images of lychee shell derived carbon ABC. Then we have sieved sepiolite with sulfur. See, it's a needle-like structure it has. Then after making it as the composite with sulfur, sieved sepiolite, and the lychee shell, it made us very nice porous structure. It is around the porous structure is very nice. It lies in the mesoporous nature. Mesoporous, as well as micropores are also available in this. See, this TEM images gives you the clear picture of the sieved sepiolite sulfur lychee cell composite. The porous structure has been studied through this. From this, the surface area has been estimated as 50 meters squared per gram, and with the pore volume of 0.116 cubic centimeter per gram, and the pore diameter is around 3.478 nanometer. After studying the cyclogaltometric and the charge discharge, it exhibits the better, see the how perfect structure CV profile it has. The oxidation, one oxidation has been happened, and the two reduction peaks are higher order and lower order polysulfide dissolution has been happened. It will be happened around 2.3 and 2 or 1.9 volt. You can see the charge discharge. It exhibits around 1500 milliampere hour per gram at the initial discharge capacity, and it reserves around 621 milliampere hour per gram even after it is cycled at cycled 100 times. This is the Coulombic efficiency of the material. From this, it can be supported with the essentially due to that 1469 milliampere hour per gram it exhibits with the Coulombic efficiency of 99%. So this is essentially due to the fact that activated carbon, first it is wrapping efficiently, and the speed of the transport of the lithium electron of the electrons and the lithium ions, and further it restrains the shuttle effect. How it happens? This actually this needle-like structure, it holds the sulfur inside sometimes, and it will not allow the material to expand. That is, volume expansion is restrained, and during the it is infused into the material. It sustains the material during the cycling. That sulfur has been restrained inside the structure. So the two ways are very easily made by the sepiolite. So that is the very big advantage of this material. However, we are further studied, interested in different carbonaceous material like carbon nanofiber, carbon black, and PRGO, MWCNT. In this, we can see the difference of MWCNT, CNF, pure material, CB, and GO. While it was compositing with the sulfur, it doesn't change much the structure of sulfur. So this will be coated in the surface or infused into the material. So that is the very interesting one. So based on this, it has been characterized with the CV, Raman, and other things. DG band occurs around 1344 centimeter inverse, and graphitic band occurs at 1579 centimeter inverse. See, this is the Pearson picture of the material. This one A, B, D, G, J are the CB, CNF, MWCNT, and the GO. The composite of materials are in the right hand side. See the semi images. Here you can see the sheet-like structure is possible. Sheet-like structure. So this is the very interesting point as far as this study is concerned, because it holds the actual sulfur into it, whereas almost all the materials are giving little bit higher initial discharge capacity among the system studied. PRGO, it exhibits very low capacity, whereas it sustains very much. It sustains very much. Why? Because it holds the material inside, and it will not leave the material during the charging and discharging and the shuttle effect. So it exhibits more than 90 percentage of Coulombic efficiency, along with the retention of 67 percentage, whereas MWCNT has a retention of 56, CNF exhibits 50 percentage, and the CB exhibits 42 percentage. So, madam, only 5 minutes. Can I?
Yes, sir. Yes, sir. No problem. Yes, sir.
Okay, madam. So based on this kind of study, we can ascertain that the PRGO gives the very good electrochemical property by restricting the dissolution of polysulfide and inhibit the shuttle effect. So we have prepared another biomass derived carbon. It is commonly named as Umatambu. So with this material also, we have made it possible to have such a wonderful capacity and sustainability. See how pure, how sharp oxidation peak and sulfur, SiO2 and Ipomia carnea composite we have used. It exhibits around 1,000. The initial discharge capacity is little bit lower. However, it sustains beyond 200 cycles. You can see it sustains 200 cycles with 62% retention. Whereas the Ipomia carnea and the sulfur has been exhibited around 47% up until 100 cycles. We cannot go beyond that. So it is yet to publish. So therefore, I will rush up. Okay. Another interesting one is kombucha scoby. Kombucha culture can be obtained from any shop, and it has been immersed in the black tea for several hours, and by adding the vinegar into it, but after 30 or 40 days, it forms a blob. Here you can see this white, and it gives you the white blob. After that, after 30 days, it can be peel off, separated out. Then it was hydrolyzed, pyrolyzed, and made the carbon material. While using this carbon material, you can see the structure of the SPAN KC. Here we are preparing the sulfur, polyacrylonitrile and kombucha culture based carbon material, and it sustains the capacity around 1666, which is the very closest value of sulfur. It's about 1675 milliampere hour per gram, and we have reported this material with a great capacity of 1666 and sustained up to 874 milliampere hour per gram after 100 cycles. So I don't want to make it more. Now I will conclude. We have developed several polymer gel electrolytes which can be prepared various approaches by means of blending, adding the plasticizer using the conventional solvent casting technique. And we have prepared the electrolytes are thermally stable beyond 140 degrees centigrade and with the acceptable transference number and reasonable cycle life. Also, we have prepared the cathode materials and in the preferred nano sizes by various techniques in order to employ it in the lithium batteries. Also, the best alternative materials like sodium, sulfur materials are prepared, and it attracted the better due to its better electrochemical performance on par with lithium. The electrolyte catalyst material for fuel cell, this is also under intense investigation in our team, and the actual sulfur composite material have been prepared with various carbonaceous material. Hitches of the sulfur electrodes have been successfully encountered by means of using the biomass derived carbon materials like kombucha culture and Ipomia carnea and other sepiolate material, clay mineral materials. So, thus the usage of various biomass-derived carbonaceous material emphasize the better platform for high-performance energy storage applications. And we have several facilities, almost XPS and ball miller, glove box, battery fabrication unit now, AFM, VSM we are having. With the TGD, TA, DAC we are having, particle size analyzer and the confocal microscope, everything we are having. So if you are interested and with the lack of facility if you have, you just come to us, and we are performing the services with a reasonable cost. And of course, I must acknowledge RUSA and the SERB, UGC, and the DST for the excellent support of funding through their projects and as well as the schemes. I must thank the audience also and the organizers for having me this nice opportunity. Thank you, madam. Thank you, the organizers, and of course, thank you, my dear participant friends. Thank you very much.
Thank you, sir. Thank you very much for your neat explanation process. And the questionnaire session is left to the audience.
Sorry, I took
Welcome the
another.
participants. Welcome the participants to ask to clear the doubts from sir.
Okay, if you don't have any question, if you want to ask me personally, means you can see that.
Sure, sir. Sure. Every day we are
I think
saying only. If you are having any doubts beyond this time
you can share
limit,
my details, contact details,
yes,
madam. No problem.
Daily we are providing like that only, sir.
Okay.
Because the participants are having many questions. If they are having any queries,
No problem.
they can also contact the resource person personally through their mail IDs.
Yeah, I have one question.
Okay.
Yes,
Hello.
Hello, madam. Tell me.
yes, ma'am. Yes, ma'am. Please.
Yeah, I have one question. Sir, you are talking about that lithium battery, right? So most of the smartphone it's nowadays is come with that lithium battery, right?
Yes.
But some of the news we heard that the mobile phone is burst. What is the reason behind that, sir?
It is mainly because of the volatility of the electrolyte solution used. Actually, normally we are using polycarbonate materials, polycarbonate or ethylene carbonate materials inside liquid inside solvent. So at one point of time, it will during the heat it will volatile. The electrolyte solution will be volatile. So that kind of oozing the elements, oozing the solvent will cause this kind of damage. It is highly inflammable, so that this kind of accidents are coming. Because of overcharging is also a very big problem. Normally, people are using the cell phone to charge in our bed, and we are keeping the holder always on. So many materials are not withstanding during overcharging. So if you overcharge, obviously the burst will happen. That means the accident will happen.
Yeah,
So this
thank
is a question from, yes, thank you, Hema ma'am. As this is the question from Anandan. Power is a major problem nowadays,
Yes.
but many of us move towards electric vehicles. Is it advisable? Due to this hike of petrol rate and
Yeah,
all,
obviously we are moving towards it. We are moving
yes.
towards it
Is
because
it advisable?
yes, obviously it is advisable. Why? Because it gives a clean environment also. Because almost all the fuels are coming from the fossil fuel. So it is depleting nowadays very much, very fast. Within another 2 decades, we are completely
Replaced with
completely eliminated the total resources. So that
yes.
after that, the electric vehicle is the only possibility. Therefore, Tesla has developed several technology, and they have made very superb cars with EV as a EV electric vehicle they have made. And nowadays, our government is preferring to have such electric vehicles
Electric
towards
vehicles.
the securing the environment.
Sure. Yes. Yes, sir. Thank you for your wonderful session. And the slides you have presented is more inspired to us and excited to us. Laboratory which you have shown that how much they are developed and how much they are
Yes, ma'am. It's very interesting.
using for the maintenance property and all. And next one that batteries you have shown, no, the lithium is going to attach with the L8 8 cell. It is very superb, simply superb to see that. We have fortunate to work in another forums also. Be blessed always with your candidates to reach many levels. Thank you, sir. Thank you, sir, for your nice time and to sharing with us and your nice presentation. Hope the participants would get many ideas to work in this alternative storage devices. Thank you, sir.
Thank you, madam. Thank you.
Thank
If it ignites anyone's mind, definitely you can call me and you can collaborate with us. No problem. You are always welcome. Thank you very much.
Sure,
Bye.
sir. Sure.
Bye.
Sure. Thank you. Thank you.
Thank you.
Shall I close, madam?
Yes, sir. Yes, sir.
Thank you. Bye.
Thank you, sir. Thank you, sir.
All the best, madam. Super பண்றீங்க. Bye.
Thank you, sir. Thank you. Thank you so much.